Hello and welcome to Podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app, you'll need somewhere to deploy it, so check out Linode. With private networking, shared block storage, node balancers, and a 200 gigabit network, all controlled by a brand new API, you've got everything you need to scale. Go to podcastinit.com/Linode to get a $20 credit and launch a new server in under a minute. To get worry-free releases, download GoCD, the open-source continuous delivery server built by ThoughtWorks. You can use their pipeline modeling and value stream map to build, control, and monitor every step from commit to deployment in one place. And with their new Kubernetes integration, it's even easier to deploy and scale your build agents. Go to podcastinit.com/GoCD to learn more about their professional support services and enterprise add-ons. And visit the site at podcastinit.com to subscribe to the show, sign up for the newsletter, and read the show notes. Your host, as usual, is Tobias Macy, and today I'm interviewing Clemens Wolf about how Congo is using Python to help communities in sub-Saharan Africa gain access to the digital age. So, Clemens, could you start by introducing yourself?
Hi everyone, I'm Clemens. My day job is I'm a software engineer at Microsoft in New York City, and I'm also the lead engineer of Congo Drc, as Tobias mentioned, which is a Canadian Congolese nonprofit. And we're using Python to empower people in sub-Saharan Africa to get access to efficient communication networks and things like that.
Do you remember how you first got introduced to Python?
Oh yeah, so that was a while ago. In college, I studied artificial intelligence as my main degree, and one of the courses there was on natural language processing. And the lecturer of that course is Ewan Klein, and he's one of the authors of the NLTK book, which is a natural language processing toolkit in Python. And so we used Python for that course, and after that, I was just completely hooked. It's a very powerful language, very clean. My programming experience before that was in Haskell, which is elegant in a certain way, but not exactly easy to understand and easy to access at first, and in Java. So compared to both of those, Python was a breath of fresh air, and I kind of used it for a bit of everything since then. Programmed a couple of games in it, lots of web services, lots of little kind of operating system scripts and things like that. Definitely great language, great ecosystem. Love also all the focus on open source. Like there's a package for literally everything on PyPI these days, right?
Can you describe briefly what the mission is for Congo Drc and how the organization got started and how you got involved with it?
All right, so the mission of Congo Drc is to connect rural populations. That's basically it. Congo Drc actually stands for Action Swaziza pour la connexion et le développement rural, which is French for Swaziza's action for connecting and developing rural areas. And the Swaziza in that acronym stands for Nzola Swaziza, who is a radio technician from the Congo Drc who founded Congo Drc. And basically, Nzola has decades of experience working as a radio technician in developing countries like the Congo Drc, Tanzania, Zimbabwe, Angola, lots of different places with lots of different nonprofits. And he always noticed a key issue, which is that all the villages where he was deployed to and where he was helping these nonprofits operate, they were always so isolated. And that means that innovation doesn't spread. There may be a great idea in village A, and then just because communication, transportation, infrastructure is all quite difficult, another village with a very similar situation very close by might not know about that. And so his idea was, let me fix that. And initially he wanted to just buy a solution off the shelf and deploy that to a couple of his communities in the Congo Drc. But then he found that there wasn't one. And so he set out to find some technologists to help him solve this project. And back in 2011, he actually developed a prototype of a solution that would enable rural communities to access efficient communication methods and deployed it in the Congo. And that was based on hacked together routers that were accessing cellular internet and exchanging an Exchange email database over that network connection. And so in that way, people could just share the cost of the bandwidth and access the email in that way and communicate very quickly. And yeah, that email access was batched, so you would only get new emails maybe once a day, but still it's a lot better than having to walk for many kilometers to the nearest communication center or to the nearest other village. So that was the initial prototype, and since then we've been working on improving that and making it more reliable and cheaper.
And so the current incarnation of that project and the primary focus of your efforts is on the Lacunae Project, which is a combination hardware and software platform. So could you describe a bit about what that platform is and how it's helping you to achieve the goals of Escudeiro as far as being able to help these communities gain access to the digital age and digital economies?
Yeah, quick backstory. Locally actually stands for a type of split drum that was used in the Congo. And so Nzola came up with that name. Back then the ancestors was using these drums to communicate. Now let's rebuild that and make it, bring it into the modern world. And specifically what we've done is we've built a hardware piece, which is based on cheap single board computers like Raspberry Pi or Orange Pi. So Raspberry Pi is $20 and Orange Pi is $10 from AliExpress. So they're quite affordable. Then we plug a USB modem into that, so that we can access cellular networks. And cellular networks these days are really everywhere. So 95% of the world's population currently has cellular coverage, and 85% in even the least developed countries. A lot of countries like the Congo DRC or Zambia, they skipped the landline phase and went straight to mobile. So even in very remote areas, you have cellular connectivity, so we can leverage that for data access. The main issue then really is that the data access is super expensive. So in the Congo, for example, $1 buys you 10 megabytes of data. Now, last time I checked, 10 megabytes of data lets me load up Gmail twice or something like that. Just, developers, as our bandwidth gets higher and higher in the countries where we're developing for our primary audiences, sites get bigger and bigger. And that means that in less developed areas, the bandwidth costs really escalate quite drastically. And so with Locally, we're trying to fix that. So we're deploying this let's say Raspberry Pi to a village, and then it creates a Wi-Fi access point. You, as a user, would connect to that Wi-Fi access point with a device like a cheap laptop, cheap phone, something like that. There are plenty of those out, and companies are always happy to donate those. And then on the Wi-Fi network, you can access our locally running email application. We made just a very simple Python Flask application for reading, writing emails that we can localize into all sorts of local languages like Lingala or Kikongo. And then once per day, or whenever bandwidth is cheap, we have some logic in there that will purchase some bandwidth from a local data provider and then exchange the emails that were written on the device with some services that we have in the cloud. And we compress them. We kind of try to save as much bandwidth as we can on that initial expensive transfer from the village to the cloud. And then in the cloud, we have some services that pick up these transmissions and unpack them, turn them into proper emails with all the MIME headers and stuff like that, and send and actually receive them. So the idea really is to, at all costs, minimize the amount of data that you have to use to get from the village to the cloud. And given that now we're also in control of when people will access the emails, or rather when we actually need to purchase the data, this is another couple of interesting properties, like being able to make use of bandwidth discounts. So as you can imagine, mobile networks aren't busy always at the same time. And so in the Congo, for example, during night times, like at 2 a.m. to 4 a.m., you can actually buy a gigabyte of data for $1. And a gigabyte, that's a lot of bandwidth, right? And so for this 1 gigabyte, we can just take an entire community's emails of 100 people or more, compress them and exchange them, and it's still just the same cost. It's still just $1, right? So basically with this platform, we can enable people to pool their resources and in that way access the service that otherwise would be out of price range.
And when you're doing this bandwidth purchase, are you introspecting the size of the data on disk at the time that you're exchanging it so that you're only purchasing as much as is actually going to be used for that particular transaction? Or are you able to purchase a larger amount in bulk and then be able to preserve any unused amount for future transmissions?
Yeah, so that really depends on the country. So right now we haven't implemented anything super clever there yet. So right now we're just purchasing a gigabyte basically, because we just assume that that'll be enough, and then we're using that to transmit. But as you say, one of the unfortunate things about that is that we do have wastage, right? So we do have the situation where we buy a gigabyte and then we don't use all of it and it will expire within 12 hours or whatever the network provider establishes there. So one interesting improvement would certainly be to be more granular in how we purchase the bandwidth and save even more in that way. However, in the countries that we're currently targeting, which is Congo DRC, Uganda, and Tanzania, a lot of times the smallest unit you can actually purchase is $1. And so during nighttime, that will still just give us the smallest unit, which is a gigabyte. And so we just go with that for our MVP currently.
As far as the actual data transfer, you mentioned that you compress it as much as possible. And when I was looking at some of the documentation for the web application, it it looks like you're using JSON for the actual serialization and data transfer format. Have you also looked at using any natively compressed or binary formats such as Avro or Message Pack for being able to decrease even more the amount of space that's required for transmitting that information?
Yes, absolutely. I'd love to do that. The only reason we're using gzip and JSON-L right now is because it's quite easy to write in a streaming fashion. So sometimes our devices, like an Orange Pi, they have half a gigabyte of memory, right? So depending on how many emails are sent, it's really good to be able to just incrementally write the compressed form, which gzip supports. But that's definitely an area that I'd like to explore more, is what sort of other compression formats and serialization formats out there could we use to reduce the bandwidth use even further. Right now we went with gzip and JSON because Python's standard library makes it extremely easy to work with those, and so that's kind of our initial proof of concept implementation. But I'd definitely love somebody to look at that who has maybe more experience in this area than I do and help out with that. That would be amazing.
And what are some of the other types of constraints that you have had to work with in terms of how you design and build the application that's running locally on the devices that you're deploying, in terms of being able to ensure that they are resilient to error conditions and able to run on the limited hardware that you're working with?
Yeah, so there are really constraints from a number of aspects, and one of them actually starts even just at the user interface, right? So how do people interact with the software? And one thing to keep in mind here is that locally, for many users, will be the first time interacting with any sort of more modern technology, right? We're really trying to bring this modern, efficient communication technology to areas where there hasn't been access to that yet, or at least not much access. And then imagine you put somebody who's never really used a computer that much in front of Outlook or Gmail, and as much work as the designers put in there to make those accessible, they're really still aimed at, let's say, Western audiences, people like you and me. So one of the design constraints we actually were working with is to make the interface as simple as possible and as uncluttered as possible so that anybody can really use it and it's self-explanatory. That's one constraint from a design point of view. Another constraint, and that was actually an interesting one, is translation and localization. So many packages will say that, well, French is a language and English is a language and German and Italian are languages, and I can translate between those. But then what happens when you're using local languages like Lingala or Kikongo that I mentioned earlier? Those often don't even have an official language code. And so that's another reason why we chose to actually build a custom email client so that we are in full control of all the strings and can implement translations for languages that may not be recognized as languages. So that was an interesting constraint from like a I8N point of view. In terms of actual technical constraints, man, there are so many things that can go wrong. So sending emails from a Raspberry Pi or an Orange Pi and dialing up to the network and things like that, there are so many tools that need to work together. So you have USB mode switch to get your modem from data mode into actual modem mode, and you have to find all the magic bytes for each particular modem to switch them into that mode, and that can go wrong and it can fail for random reasons, and you don't have any debugging output except for the color of the LED of the modem. Then you have WV dial to actually do the connection, and one big constraint and issue there is how do you get the correct credentials and the correct configuration to dial up to a SIM card from, say, the Congo DRC or Benin. And GNOME actually maintains a database of configurations for a lot of SIM card providers. So, for example, they have support for Vodacom and Orange in the Congo, but in some countries are completely underrepresented in that database. So I was recently looking into setting up a locally for Benin, and there are 0 configuration entries in the database for Benin. So it's like, now I have to reverse engineer the SIM card protocol for this particular provider in Benin and see how to actually connect to that. And often that's very difficult to do. Like, I'm based in New York City right now, and so that adds another layer of complexity on top of that, right? Like, how am I gonna dial with a SIM card from the Congo into, let's say, AT&T network in the United States, right? So that's another level of complexity. And then in terms of retries and fault tolerance, network connections are unreliable, especially in developing countries. And so we have to have a lot of robustness and reliability in there so that if the emails don't manage to get sent this time, they'll get sent, on the next scheduled update and things like that. So it's definitely a lot of trial and error and a lot of robustness engineering that needs to go into a product like this. And another constraint, of course, also is once you've shipped the product, it's shipped. And it'll be extremely difficult to actually update them because the update would consume a lot of bandwidth. So we don't want to burden our users with having to pay for that. So it's really a lot of upfront testing necessary.
Yeah, I was going to ask about the update aspects of how you manage to release patches or bug fixes, whether that's something where you would have to go and physically, swap out an SD card or perform the software update in place when you're physically present with the device, and how you would manage that from a scalability perspective. And then as a second question on that, I was curious who the actual customer is for these devices, as far as who's actually purchasing them, and how you maintain power for them to ensure that they're usable by the various communities where they're deployed.
Right, so for the update path, right now we don't have a good model for that. And I mean, there are several technical solutions, like you can set up a SIM card to receive SMS messages, and you can use Twilio to send those SMS messages and then remotely trigger maintenance actions, right? That's how you normally do this in an IoT project, or you can use a product like Azure IoT Edge or whatnot. Like there are a bunch of ways in which you can trigger an action on a remote device, but then we don't want to burden the user with the bandwidth cost, as previously said. So one way that we thought about that, if there really is a very critical update that we need to do, is we aim to have ambassadors in our target countries, like people who are really bought into the project, and basically fund them to go around the various communities and swap out the SD cards and transfer the data and things like that. And so we'd basically train them to run a couple of operational scripts to transfer the data from the old device to the new device, and then update the software by swapping out the SIM cards, the SD cards rather. But that's definitely a hard problem and something where I don't feel as though we have a very satisfying solution right now. In terms of who actually pays for this, so that's an interesting question. So we're definitely targeting rural communities, and the idea is that community would come together, pool their money, and purchase one of these devices. And that's something that Nzola actually verified in 2011 with this initial prototype, that there is definitely a market for this. And people were just so keen and so eager on buying that prototype and continuing to work with that. However, we also do realize that oftentimes this may slightly be out of the reach of some communities. And so one of our thoughts there is to market the device to nonprofits that often have operating budgets. For example, we were talking with PODA and For the Love of Africa. They're two Canadian nonprofits that are operating in the Congo and Uganda, and sell the devices to them, and they would deploy them to their community health clinics and their libraries and their schools and operate them there, and slightly mark up those devices over the actual cost of the hardware, and then use the funds from those deployments to subsidize actual local purchases. So let's say you're a village in Bumbu and you want to purchase one, you'd pay price X, and you're a nonprofit, you'd pay price X plus some markup that we'd use for subsidies going forwards.
And as far as the actual workflow for people in these communities who are interacting with Lacunae, can you walk through what that interaction looks like for somebody who's first coming across it, and then as they use it for being able to manage their communications with the platform?
Sure. So let's say somebody purchased a Lacunae for your village, or a Lacunae just arrived. You plug it into a power source or into a solar panel. So we actually did some tests, and we can element the Orange Pi and the Raspberry Pi with a simple solar panel. So you plug that in, it powers on, and it creates a Wi-Fi network. It has some default credentials. You connect to that with your device, and then you just make an account. You go through a simple flow in our Flask app that asks you what's your name, what's your password, and then it allocates an email address to you. And that email address will be your name at the location of the device. So there is a hard-coded string that gets created at device allocation time. That is a unique identifier for that device. Let's say the name of the village, like Bumbu, or the name of the nonprofit in a particular project. And then after you complete the sign-up flow, you have an email address that's your name at devicename.locale.ca. And then you'll be able to, in the UI of the email application, write emails. And then the next time that it synchronizes, those emails will get transferred to the cloud, sent, and anything that was sent to your name at devicename.locale.ca will get downloaded, and you'll be able to see it in the email application. So it's a very simple flow from a user's point of view, which is the basic email flow. And then this is something that we're currently working on to build on top of that, to add more value via email beyond just communication. Is, can we make integrations that use the email protocol and give you more rich information? And the inspiration for that really was when I was living in Zambia in Southern Africa. I was doing correspondence courses for German, and I would receive lessons via snail mail and complete them, and then do some assignments and pop them into the snail mail again, and eventually I'll have them graded. And then that led to the thought of, can we use email to recreate this education access, for example. So we're currently talking with some teachers, like retired teachers organizations in Canada, to see if there would be people who'd be willing to donate some of their time to, for example, remotely teach a classroom via email. So that as a student, you'd sign up for a classroom, you send an email to a particular mailbox, and then that gives you back the list of all the classes, and then you register for a class also via email, and then we would parse that email and sign you up on the service side. And then the teacher would send you assignments via attachments, finish them, and reply with your solutions to that email, and we can basically stitch all of those courses and all of that correspondence together via some identifiers that we include in the email, a bit like how you can send email messages to respond to GitHub notifications and things like that. So that's one service that we want to build on top of the email protocol. And then other things like access to medical databases. Let's say you send an email to a particular mailbox, like medical data at locally.ca, and there's a query in there. We execute that query for you, searching against some medical databases, and give you back all the results. There are so many information flows that you can build on top of this communication protocol. It's a bit like the recent trend with chatbots, right? There are so many things that you can encode in a conversation between two people, and then the transfer protocol between that, in our case, would just simply be email, because then we can re-leverage the entire infrastructure, compression, and all that good stuff.
And beyond the types of services that you're thinking about building, what are some of the other use cases that these communities have for using email as their window or gateway into the broader internet? And what are some of the limitations that are imposed by that being the only interface?
Yeah, so it's kind of interesting because, as you say, email is a bit limiting because it's asynchronous, it's scheduled, it's time delayed, right? So how useful can it really be? And from my experience, it's really quite useful, and there are not that many things that you can't model in this kind of email conversation flow. So a really surprising use case actually was this for agriculture. So my dad actually is an agricultural engineer and has been working his entire career in rural development in African countries. And one of the big issues in rural development is if you're, let's say, a subsistence farmer and you still sell some of your products, and to make a bit of money on the side, you live in village X and then you go to village Y to sell your wares on market day, and you have to make a choice on the types of wares to bring. And sometimes you're lucky and you make the right decisions and you sell everything, and sometimes you don't sell everything and then you have less money available. So one super interesting thing over email that we could also do that I never thought about before is to make this marketplace via email, where you may basically make purchase orders and offers via email, and then you only need to bring the things that people already basically paid for to the market day, and just collect the money and exchange the goods. So that's a really cool thing that we can build on top of that, and something that I didn't consider you could actually model as an email interaction beforehand. Then some things, of course, you can't really model as this asynchronous flow, and those are browsing scenarios where you're just, I don't know, checking Facebook or doing a random research and following links and things like that. That would be really frustrating over this time delayed flow. And for that, we don't have a great solution with Locally right now, but there are several other projects that offer you access to some information that's more read-only style. Let's say I'm on a blog reading some stuff, and then I follow a link to another blog. I'm just consuming, I'm just reading, right? I'm not communicating back to that medium. And so that's actually a slightly different problem and can be solved in a different way. So for example, we're working with Outernet recently, which is a project that uses some spare satellite frequencies by the European Space Agency to broadcast a read-only copy of the quote-unquote useful internet over satellite. And then you can just add a satellite antenna to your Raspberry Pi and receive that data anywhere in the world for free. And they broadcast Wikipedia, they broadcast various blogs, various news articles, things like that, weather data. So you can get all of this read-only data with a different channel than Locally, and you can consume it in that way. And once we have a technology deployed in a village, there's so many things we can build on top of that. Like, for example, this Outernet integration. And then we can use Locally for basically read-write communication that's asynchronous and time delayed, and other mechanisms such as Outernet, or there are other projects like Internet in a Box, which put Wikipedia and a bunch of other stuff just in a static copy on a device, and use that for the more read-heavy flows with more interaction that wouldn't be modeled very well via email.
And so now that we've covered a bit more about the user interaction and some of the high-level design aspects, can you dig a bit more into the mechanics of how the system works, both on the Locale web application side as well as the cloud service that you have backing it?
Totally. So on the Locally itself, we have a Flask application, simple, Flask application with all the good stuff with Flask login and Flask assets and all of that standard stuff that you'd have for your standard server-side rendered web application. I really like Flask because it makes a lot of things super easy, and there's a middleware and a plugin for everything else. And it makes it also super easy to make very simple and robust sites that work on a lot of browsers. So we have fairly minimal JavaScript just because the kind of devices that will be used will be fairly low end and potentially quite old. And so fairly limited JavaScript, fairly limited CSS. And Flask makes all of that stuff really easy. On the locally, we also have another Python script that's a really cool script called make vvconf, which is a script that takes this database from Debian that I mentioned earlier from GNOME that has all of this information about various SIM card providers and then parses that. It's a big XML file basically, and parses that and spits out a configuration file for vvconf, which is a tool in Unix to dial up an actual modem connection. And that tool is written in Python. And actually, it was distributed as part of Arch for a while, I think, and then the maintainer dropped it or something like that. And anyways, it supports like Python 2.0 or something like that. And so I recently forked that and modernized it and made sure that it runs on Python 2.7 and later. So we maintain a fork of that. And it's a really cool tool, and more people should be using it and really contributing to that database of SIM card information, because it just makes the world a better place for everybody and for every Ubuntu installation. Every time that you put a USB modem into a Linux box, basically using that database, right? So the more data we can get in there, the more information we can get in there, the better. And then on the service side, so we're hosted in Azure currently because we're nonprofit, so we get a grant from Microsoft of $5,000 cloud credits per year, which right now covers everything that we're doing. And we have a bunch of services deployed to Kubernetes just to make management easier. And we're using a really cool framework there for the actual web API side, and that is Connection by Zalando. And basically in Connection, you write a open API or Swagger file describing your API. Like let's say I have endpoint A and it takes a post request, and in the post request body, you have, let's say, the name of the client, and then in the URL parameter, you have a token, and in the header, you have something else. And then you just add an annotation to that, and that annotation is the fully qualified path to a Python function. And then Connection will take care of taking the request, validating that all the data that you said is there in the different parts of the request, and then just calls your function. And that's just a normal Python function at that point. It's not even aware that it's part of a web framework. It just gets the different data that Connection pulled out from the request, passed into it as arguments. And that's super powerful because, first of all, you write the Swagger file first, so you have really good documentation for all of your APIs, and you don't need to write any custom code for validations and data serialization, all of that stuff. That's a really cool framework. We're also using SendGrid as the actual email provider. So when we send an email that was transmitted from a locally, eventually it ends up in the cloud, and then we're using the SendGrid Python SDK to send those emails. Also super easy to use. This, as I said, is something I love about Python, right? There's a library for everything, and usually the libraries are quite delightful. And then we're also using a bunch of asynchronous mechanisms in queues to make sure that we can scale appropriately and we don't drop connections just because currently we're processing a really large email and things like that. And that's actually an area in Azure where the Python support is a bit lacking. So there are several really good queue technologies in Azure, like for example, Service Bus and Azure Storage Queues, but the Python SDKs are all based on polling. They're all based on the REST API, unfortunately. So to get the messages, you can't just say, here is a message handler, call this whenever a new message arrives. You actively have to go out every 30 seconds and fetch new messages and act on them. So that's a bit lame. So to work around that, we actually used a container pattern called Ambassador Container, where we have a Python endpoint written in Connection that just sits there. And then we have a sidecar container to that, like a container that's scheduled to the same node that actually uses the C# SDK for Service Bus, which has an AMQP implementation, and so has kind of push notification style message receiving. And so whenever the message gets received, it then takes that and posts it to the service that actually does the message processing. So in that way, we get the best of both worlds. We can implement our logic in Python, and still we can get this really efficient asynchronous communication via Service Bus and the C# SDK there. We're also doing a bunch of interesting stuff with images recently. So let's say you're writing an email in Gmail and you're including an image in that. Usually those get included as a link, right? And then when those get transmitted to locally and somebody opens the email, there isn't an internet connection there to actually display the image. And so we recently pushed an update where now when we receive the email, we actually parse it, and any image that you have inline in the body, we automatically fetch that base64 encode it and put it into the email so that you can actually then see it on the locally. And we also resize it to save space and to save bandwidth as much as possible. And we're using the Pillow library for that, like really good image manipulation in Python.
And on the client side, Python is definitely easy for doing development work, but for being able to target these lower end devices, it works well on Raspberry Pi, but for as you get smaller and you're trying to save on energy consumption more, it oftentimes pays to have the trade-off of using compiled languages. So I'm wondering if you've looked into using anything like Python or MicroPython or even a different language implementation for building the client-side application.
We haven't really looked into that much yet because, yeah, we kind of want low-powered devices, but not really. We're not really targeting low-powered devices. We're just targeting the cheapest devices out there that often happen to be a bit underpowered. Like Orange Pi is $10 and it has quad-core processor with 1.6 gigahertz and half a gigabyte of RAM. So that's kind of low-powered, but not that low-powered. And if you go much lower than that, we'd actually have issues finding the kind of hardware that we need because we need at least one USB port for the USB modem to do the dial-up connection, and the board also needs to be able to supply sufficient power to that USB port. And so a bunch of the more low-spec boards actually don't supply enough power for one of those USB modems. And so there is definitely a trade-off there, but I'd say we're targeting the level where, let's say, we have half a gig of RAM, and let's say like one plus gigahertz processor or something like that, which is not that low powered. And so Python works pretty well in that context. And we're doing the entire, setup with Nginx to serve you static files and GUnicorn and things like that to ensure that different parts of the stack handle different things. And so overall, we utilize the resources fairly well. One thing that would be interesting though is if we can find a board that is competitive in price with Orange Pi, so like $10 or less, and then do the USB modem, the kind of dial-up connection in a different way, like let's say with a custom GSM chip or something like that. And there are a bunch of things coming out in that space recently, but I haven't looked very deeply into those yet. Like I'm not really a hardware person, so that's not the reason we actually went with Orange Pi or Raspberry Pi and Python, because it's super simple to get up and running. It's kind of super simple to find contributors and to have them be productive quickly. That's definitely something that would be interesting to look more into.
And beyond some of the technical limitations imposed by the environment and the platforms that you're deploying to, what have been some of the most challenging or unexpected aspects of building and maintaining Lacunae and interacting with the user communities?
So there are a couple there. So one of them actually is right now, Ascodero, we're an entirely non-profit and we're entirely volunteer run. And as you can imagine, everybody's super busy, and so it's difficult to find consistent time to work on these things. And I work on it nights and weekends, but it would be great, to have more developers involved. And this summer we have a couple of students from Cornell University. They have a Tech for Good club and they're helping out with a couple of projects, and that's super cool. I'm so excited about that. But finding reliable contributors that you can count on to actually work on and that can take technical decisions with you and everything, that has been absolutely a challenge. And yeah, I mean, we're entirely open source. I think we're kind of working on a cool project with lots of different aspects from low-level stuff to cloud. So there's really something here for everybody. And still, it's difficult to find people who say, okay, I'll sign up for this for 2 hours a week or 4 hours a week or however much, and then actually stick at it consistently. So that's a challenge. I guess it's a challenge in running any sort of open source project. Another technical challenge, or another non-technical challenge rather, is, as I mentioned before, just the lack of presence of many of sub-Saharan African countries in the internet in general, right? So this database of all the SIM card providers has 0 entries for Benin. How are you going to deal with that? And that's not really an issue. Let's say if you were going to deploy locally to, let's say, Canada. Actually, in Canada, there are some regions, some remote regions that have very similar connectivity problems to sub-Saharan Africa, just because there isn't cell phone network there, and internet via satellite is super expensive, right? And then I was speaking with some people who were on a very far north in British Columbia research station most of the day, and then once every now and then they dial up via their satellite internet, and then Windows updates and downloads a bunch of stuff and eats up all of the bandwidth. And that's not ideal, right? So even in those situations, it would be useful to use locally. And that's much easier in terms of configuration and deployment because, Canada, British Columbia, lots of resources about different providers that you can access, etc. Not so much the case for, let's say, the Congo or Zambia or Benin or Uganda.
And going back a bit to the aspect of having an email be the only interface to the broader internet, I'm curious about the problem of discovery as far as how the user would even know what email addresses are available for them to be able to send correspondence to or be able to request information from for whatever their particular needs might be.
Yeah, that's a great point, and we can address that in two ways. One of them is we currently compile a static list of the kind of useful email addresses, the services on top of email that we've implemented or that we are implementing into the client at creation time. Obviously, that's a static list though, so it's useful because there are only so many services that we can think of right now. But then in terms of updating that, we're thinking about actually uploading that list of the kind of directory of useful email addresses to the Outernet and broadcasting it in that way. And the Outernet integration is quite a bit more expensive because you need to have a satellite receiver and a bunch of hardware to decode the satellite signal. So it would only be really feasible for, let's say, nonprofits who are deploying that solution to really afford that upgrade. It's about $200 in total or something like that. But then you at least have a couple of hubs that have always updating list of all the useful mailboxes that you can send emails to, and then you can use word of mouth basically to spread that further, in addition to the hard-coded list that's compiled into the client at deployment time.
And also, as another means of being able to update that information, have you considered having sort of a default mailbox that's built into the device that when you deploy it, it is able to receive email messages and then display them as a notification or allow people to navigate to that mailbox to be able to review the information that's there, to be able to then update those lists or provide opportunities for being able to communicate with various people or services or organizations?
No, that's a great idea to have sort of like a newsletter of these are the services that you can use now, and just send that out regularly to each of the devices. Yeah, I hadn't thought of that. That's a brilliant idea actually. It'd be super easy to implement, and just have that as, let's say, a special account on a device, and there's a tab that you can go to always see all the messages sent there. That's a great idea actually. I should look into that. I'm gonna track that in a GitHub issue right after this podcast.
All right. And so beyond Lacunae, are there any other projects, either technical or non-technical, that you are planning on or starting to implement as part of the mission of Ascoderu?
So right now we're really focused on local and getting that out of the door, and then seeing where we can take this email service basically, and how many things we can build on top of that. Just as another example, recently there were elections in the Congo DRC, and one of the big issues with that election was that a lot of parts of the population were excluded from that just because it's difficult to get to the next polling station, etc. And so Zola was thinking, what if we can work with the government to have signed emails and to actually verify somebody's identity based on an email, and then use that for voting, right? So there's so many things that you can build on top of that, and I think this email protocol is going to keep us busy for quite a while. But another thing that we also wanted to look into is how can we leverage what we built and use it to empower other nonprofits with similar missions. I spoke about Internet in a Box earlier, which is a great nonprofit and mostly operating in Southeast Asia, to my knowledge. And they basically distribute like a Library of Alexandria style Raspberry Pi with Wi-Fi to communities so that people get access to this read-only information. And we were talking with them to integrate locally with that so that whenever people go to these hubs to, let's say, read Wikipedia or look up Khan Academy or something like that, they can also exchange messages with other people who went to the same location, and maybe exchange like pointers to great information on the device or whatever, to have a bit more interactive component there. And so one of the projects from the Cornell University this summer is actually to work on integrating locally with Internet in a Box. And so I'm sure there are other nonprofits out there that are operating in a similar space that we can help out with the things that we already built.
And are there any other topics of discussion or aspects of the project and the work that you're doing that we haven't covered yet that we should discuss before we start to close out the show?
So one thing that I find quite interesting is how increasingly technology comes to the focus and to the forefront of so many issues, right? We recently had all of these issues with privacy, with Facebook and things like that. And then, you have self-driving cars and how is that going to affect the car industry? but also technology is core to development and to innovation. And there's actually an initiative at the United Nations called the Sustainable Development Goals, and that's a set of ideas and of targets and metrics of how we as a planet can measure our progress towards, getting everybody out of poverty and getting to a sustainable future, even for the Western world. And one of the things they clearly call out is the importance of technology. So they have the Sustainable Development Goal 9, which is about building resilient infrastructure, promoting inclusive and sustainable industrialization, and fostering innovation. And that's something where we as technologists can really get quite involved and help out with, because we've been doing this for a while, right? And as I said earlier, 95% of the world population has access to mobile cellular signal. So one thing I'm quite interested in is how will this go forward? That there is this increased focus on technology and on innovation, technology and development, and what can we as technologists do to help empower that and to accelerate that.
And for anybody who wants to get involved or contribute to the work that you're doing, what would be the best way for them to do that?
Oh, yes, please. So all of the things we're doing are open source on GitHub under permissive license. So you can find our issue trackers. I marked a couple of them as good first fixes. So if you just want to jump right in, get your hands dirty, that's an easy way to get involved. There's really something there for everybody, from low-level Linux hardware interfacing with modems and stuff like that, all the way up to Kubernetes and cloud services and everything in between on the stack. That's a great way to jump in, or just open up an issue, introduce yourself, or send me an email directly to clemens@ascoderu.ca, and I'll respond to that as soon as possible. We also have a Slack channel that we use for all of our communication. You still have to get an invite to get to that, but everything that basically we communicate about is totally open. So we want to be super transparent as an organization. Yeah, so reach out on GitHub or reach out to me via email and we'll find something, or find me on LinkedIn, send me a message there.
And for anybody who does want to get in touch, I'll be sure to add your contact information to the show notes. And so with that, I'll move us into the picks. This week, I'm going to choose HubSpot. They've got a free CRM that you can use, and I've been leveraging that recently for being able to keep track of various conversations I have around the podcast. So it's been very useful for getting organized for that and tracking tasks and emails that have been going back and forth. So if that's something that you are battling with, it's definitely worth checking that one out. And with that, I'll pass it to you, Clemens. Do you have any picks this week?
So this week is super hot and humid in New York City, which reminds me a lot of when I was living in Mali in West Africa, and that always reminds me of Ali Farka Touré, great blues musician, desert blues of Mali, Rolling Stones top 100 guitarist of all times. If you haven't heard any of his music before, definitely check it out. It's super, super interesting.
All right. Well, thank you very much for taking the time to join me and discuss the work that you're doing at Escudero with Lacunae. It's definitely an interesting project, and I'm interested to see how it pans out as you go forward. So thank you for that, and I hope you enjoy the rest of your day.
Yeah, thanks so much for your time, and to everybody for listening.